Here we have a SAT math problem. Okay, let's go to the question. In rectangle ABCD above, AB equals to 8, BE equals to 4, FD equals to 6, and BC equals to 20. If line segment BD and line segment EF intersect at point G, what is the area of the shaded region? Okay, in the given figure, we have the length for this line segment AB, that is 8, and also we have the length for this line segment B, that is 4, and we have the length for this line segment FD, that is 6. And also we have the length for the side of the rectangle BC over here. Its length is given, that is 20. Okay, using these information, we have to get the area of the shaded region over here. Okay, to get the area of the shaded region, we have to get the area of this triangle BGE over here, and also we have to get the area of this triangle, that is DGF over here. Once we get the areas of these two triangles, we have to add them to get the area of the shaded region. Okay, here ABCD is a rectangle. Since it's a rectangle, opposite sides are parallel and equal in length. So the line segment BC and AD are parallel and also equal in length. Now let's consider the triangle BGE over here. For this triangle, we can consider this line segment BE as the base because we have the length for this side of the triangle BE. And also for this triangle DGF over here, we can consider this FD as a base because we have the length for this side of the triangle FD. And these two triangles have their bases BE and FD on the parallel lines BC and AD. And also these two triangles have the common vertex G opposite to their bases BE and FD. Since these two triangles have their bases on the parallel lines and a common vertex opposite to their bases, we can say these two triangles BGE and triangle DGF are similar. Now let me write the ratio of their bases BE and FD. Let me write over here the ratio of the bases BE and FD equals to 4 to 6. Okay, here for both the terms of the ratio, we have the greatest common divisor 2. We can divide this one and this one by 2. When I do so, I am getting 2 to 3. So the ratio of the lengths of the bases for the two triangles is 2 to 3. Since these two triangles are similar, in whatever ratio we have their bases, in the same ratio we'll have the heights of these two triangles. Okay, so where do we have a height for these two triangles? Let me draw a vertical line through the common vertex G over here. Okay, here it's a vertical line. Since it's a vertical line, it has to be perpendicular to BC and also perpendicular to AD. Okay, here let me mark H and here I. This GH represents the height for the triangle BGE over here, and this GI represents the height for this triangle DGF over here. As I said already, in whatever ratio we have the bases, in the same ratio we'll have the heights GH and GI. Okay, now let me write the ratio GH to GI equals to the same ratio in which we have their bases, that is 2 to 3. Now, from the terms of this ratio, we can get the actual length of GH and GI. Okay, to get the actual length of GH and GI, what we have to do is we have to multiply the terms of this ratio by the same non-zero number, say x. When I multiply this 2 by x, I am getting 2x. 2x is the actual length of this GH. And when I multiply this 3 by the same non-zero number x, I am getting 3x. 3x is the actual length of this GI. Okay, here I got the heights of the two triangles. That is GH is the height of the first triangle. Its length is 2x. And GI is the height of the second triangle. We have over here, its height is 3x. Okay, here when I add this GH and GI, that is equal to the length of this vertical line segment HI over here. So that is 5x is the length of this vertical line segment HI. But the length of this vertical line segment HI is 8. Because the length of this vertical line segment over here is 8, the same length we can consider for this one as well. So then 5x must be equal to 8. Okay, now let's solve for x in this equation. For that, we have to divide both sides of this equation by 5. Then this 5 will cancel out. X equals to, when I divide 8 by 5, I am getting 1.6. Okay, now to get the length of GH, I have to plug in this 1.6 for x over here. When I do so, I am getting 2 times 1.6. 2 times 1.6 is 3.2. So 3.2 is the height of the first triangle. Let me write over here. And now to get the height of the second triangle GI, I have to plug in this 1.6 for x over here. Then I'm getting 3 times 1.6. 3 times 1.6 is 4.8. So the height of the second triangle, that is the length of this GA, is 4.8. Okay, here for both the triangles, the base and height are clearly known. Now let's get the area of the shaded region. Okay, let me write the stuff over here. Area of shaded region. Okay. To get area of shaded region, I have to add the areas of the two triangles. Okay, now let me get the area of this first triangle. For that, we can use the formula base times height divided by 2. Here, what is the base of this triangle? That is 4, and the height of this triangle is 3.2. That is 4 times 3.2 divided by 2 positive. Now let's get the area of this triangle. For this triangle, the base is 6 and the height is 4.8. That is 6 times 4.8 divided by 2. Okay, here 2 goes into 2 1 times and 2 goes into 4 2 times. Here 2 goes into 1 times and 2 goes into 6 3 times. Okay, here 2 times 3.2 is 6.4, and here 3 times 4.8 is 14.4. Okay, here now we have to add 6.4 and 14.4. When I add them, I am getting 20.8. Therefore, the area of the shaded region is 20.8 square units. We find this value 20.8 in answer choice B. The correct answer choice for this question is B.